So today we will teach you how to solve for Fourier series. For our given, we have our function of x is equal to x over 2 and its ranges are 0, x, 2 pi. So first thing we need to do is substitute x to the function of x. Therefore, y is equal to x over 2. And then we need to substitute the range. If x is equal to 0, then y is 0 over 2, which is equal to 0. And then we need to substitute the other range. If x is equal to 2 pi, then y is equal to pi over 2. That is our range. Now we need to plot. We need to know the x and y components. So in here, our x is 0 and our y is 0. And in here, our x is equal to 2 pi and y is equal to pi over 2. And then the next thing we need to do is we need to plot the coordinates. We'll do our Cartesian plane, and then we will plot our points. Pi, negative 2 pi. This is negative pi and negative 2 pi. Pi, 2 pi. And this is pi. So we need to plot the first point. First point is 0 and 0. And then we need to plot the x-axis, which is equal to 2 pi. And then the y-axis, which is equal to pi over 2. So this is the range now. Then the next thing we need to do is we get for the AO. The formula for AO is equal to 1 pi integration of our function of x dx. So AO is equal to 1 over pi integration of x over 2 dx. We further simplify this and we will get 1 over 2 pi integration of x dx. We will have to know our limits, which is 0 and 2 pi. After we integrate, we will come up with the answer of AO, which is pi. The next thing we have to do is get the AN. AN is equal to 1 over pi f of x cosine nx dx. AN is equal to 1 over pi. Same with getting of the AO, we need to put our limits. And the function of x cosine nx dx. We further simplify the equation. We get 2 pi 0 x cosine nx dx. And then we will integrate. This is x and this is cosine nx. We will get the derivative of this 0 and the integration of this 1 over n sine nx negative 1 over n squared cosine nx, then positive and then negative. Now we will group them. AN is equal to 1 over 2 pi multiplied by the integration. We got 1n over x sine x as 1 over n squared cosine nx. Then put our limits. and then we just substitute, and we will now get an is equal to 0. The next step we have to do is we are gonna get the bn. Same as the an, we will also integrate here. So with this 1 over pi, the limits 2 pi and 0, x over to the function and the sign, and x dx. And we will now further simplify 1 over 2 pi, the limits 0, x sine and x dx. Then we will derivative 1 x 1 0 sine and x negative 1 over n cosine and x and negative 1 over n squared sine and x. Positive, negative, and we will now group them. And then we will now substitute to the integration, and we will get 1 over 2 pi multiplied by negative 1 over pi x cosine and x plus 1 over n squared sine and x, and we're gonna put the limits. After that, we're gonna substitute the limits, and we will get the answer of negative 1 over n. After that, we will substitute what we got into the main formula. The main formula is a over 2 plus the summation of n is equal to 0 to infinity, then an cosine nx plus bn sine nx. Since ao is 0 and no is 0, we would cancel them up, and we would only get f of x is equal to pi over 2 plus the summation n is equal to 0 to infinity negative 1 over n sine nx. And that is the final answer for the example.